Hello students, welcome back to Vihan Pratik Institute of Education and welcome back to online mathematical classes. I am your facilitator M. Shiva Kumar and we are discussing chapter number 9, applications of trigonometry. These applications are real time or real life based applications. In that we are discussing 9.1, exercise 9.1 and problem number 12. So in problem number 12 it states that from the top of a 7-meter high building, the angle of elevation of the top of a cable tower is 60 degrees and angle of depression. Now students, we have discussed 11 problems. In 11 problems we never came across the word angle of depression. Now this is new to us and we'll discuss a little deeper into this term in this class. So the angle of depression of its foot is 45 degrees. Determine the height of the tower. So see students, this is the height of the building. This is the height of the building and this is the height of the tower, which we don't know. H, we don't know. Now this is the top of the building. From top of the building there is an angle of elevation. Angle of elevation in the sense looking upward. I'll write it here. Angle of elevation means looking up. Then here we have angle of depression. So this is angle of depression. Angle of depression meaning looking down. Okay students, so when we look up we have an angle of elevation. When we look down we have an angle of depression. So angle of elevation is 60 degrees. So when the person is looking, observer is looking up, the angle is 60 degrees. When he is looking down, the angle is 45 degrees. So same I have drawn here. So this is the height of the building, 7 meters. So this is the angle of elevation up. This is the angle of elevation down. Okay. So we don't know the height of the tower. So this is the height of the tower, which we don't know. This is the height of the tower, which we don't know. We need to find out. Okay. So let's discuss what is angle of elevation and angle of depression. So in order to have an angle of elevation or angle of depression, we should have a reference direction. Reference direction. Now let's assume there is a person at this point and is looking up, making angle of elevation, looking down, making angle of depression. So to look up and look down, we should always have a reference point. That reference point is called as horizontal line. So this is the horizontal. With reference to this horizontal line, we refer angle of elevation. Now this is line of sight, looking up, line of sight. This is also line of sight, looking down. Line of sight, looking down. So to look up and look down, we should have a reference, and this reference is called as horizontal line. So with respect to horizontal line only, we measure all the angles. Now angle AEAD. So angle EAD is called as angle of elevation with reference to this horizontal line. So then this will become angle of elevation. So I'll write it as angle A, angle of elevation, or angle AE means angle of elevation. So with reference to this same horizontal line, he is looking down. So the angle made with respect to this horizontal line is called as angle of depression. So same angle A, but here we have D. So horizontal is very important. So without horizontal we cannot solve these problems. Okay, right. So let's write down what is given. Let or given, let the height of building which is equals to AB equals to 7 meters. That's it. Okay. Since we have drawn a horizontal line AD, so include that also. Draw a line AD parallel to BC. So this line, this is the line which we have drawn. AD which is parallel to BC. AD is parallel to BC. Now from the figure, what we have? We have two right angles and one rectangle. So first we'll check the right angles. How many triangles we have? We have triangle AED, AED. We have triangle ABC. We have triangle ADC. All these three are right angle triangles. Okay. No, sometimes ADC cannot be a right angle triangle, but it is a triangle. Okay, it is a triangle. But AED is a right angle triangle. ABC is a right angle triangle. Along with this, we have one rectangle. Rectangle is ABCD. So what are the properties of rectangle? Rectangle has opposite sides equal. Okay. So in rectangle, sides AB is equals to CD and BC is equals to AD. So these are the properties of rectangle. Okay. So now we'll solve this problem using this rectangle along with right angle triangle. Okay students. So we'll do in next paper, next page. Okay. So ABCD will become rectangle with sides AB equals to CD equals to 7 meters and BC equals to AD, which we don't know. Okay, right. Now consider triangle ABC, but we don't know the angle C. We know angle, we know angle A. We know angle A. Angle A equals to 45 degrees, angle of elevation, but we don't know angle C. Now how we can find out angle C? So if we assume AD is parallel to BC and AC has transversal, then angle A is equals to angle C by interior or alternate interior angle theorem. Okay. So it means that angle A, which is 45 degrees, is equals to angle C, interior opposite side, opposite angles, or interior alternate angles. Okay, therefore angle A is 45 degrees, therefore angle C is 45 degrees. So from triangle ABC, if we consider trigonometric ratio tan theta, which is equals to opposite by adjacent, here tan theta is tan 45 degrees, which will equal to opposite is AB divided by adjacent is BC. Okay, adjacent is BC. Okay, right. Now we know that AB is 7 by BC, and from trigonometric ratio tan 45 is 1 equals to AB by BC, which will equal to, therefore BC equals to AB, which is 7. BC equals to AB, which is 7. So AB is 7, therefore BC equals to 7. Therefore this is actually a square. ABCD is a square. We assumed ABCD as a rectangle, but it is actually a square. So our assumption that it is a rectangle has become a square. Okay, right. Then we'll continue to find next triangle. Okay, therefore BC is 7 meters. Since they are opposite, AD will become 7 meters and DC will become 7 meters. That is, AB is equals to CD, which is 7 meters. BC equals to AD, which is also 7 meters. Okay, so it's a square. So we assumed earlier to be rectangle, but it is a square. Now consider triangle AED. So from this, tan theta equals to opposite is ED by adjacent is AD. We know here the theta is 60. So tan 60 equals to, we don't know ED, so we'll write ED as it is. We know AD just now we found out, which is 7. And tan 60 is root 3. So root 3 equals to ED by 7, which will equal to ED equals to 7 root 3. Now we got ED. The total height of the tower height is equals to CE, which equals to ED plus CD. So this height plus this height, already we know the value of CD is 7 meters. Just now we found out the value of ED, which is 7 root 3. So which will equal to 7 root 3 plus 7, which will equal to, if you take 7 common, root 3 plus 1 meters is the height of the tower. So height of the tower is 7 root 3 plus 1 meters. Now if we want more precise value, just multiply root 3 value 1.732 plus 1, which will equal to 7 into 2.732, which will equal to 19.12 meters is the answer. Therefore the height of the tower is 19.12 meters, students. Please go through the video, solve by yourself, understand the concept of angle of depression, how we are using the horizontal line, understand it. Please solve by yourself. Whenever you got doubt, please text me in the YouTube channel or message me. I hope everyone has understood the problem, mainly the concept of angle of depression. Thank you, students. Thank you very much.